Now see here, there is a hollow cylinder and a solid sphere. Both are having the same mass m and both are having the radius r. Both are given equal torque, that is tau. In that case, you have to identify here which one will acquire greater angular velocity. So see here in this question here, we know torque is equal to I1 alpha 1 and torque is equal to, here for the sphere we can write I2 alpha 2, and here we know it I1 alpha 1 is equal to I2 alpha 2. I1 for this hollow cylinder we can write mr square alpha 1 is equal to 2 upon 5 mr square alpha 2. So this r square, this will get cancelled. So we will be getting alpha 2 upon alpha 1 is equal to 5 upon 2. That means alpha 2 is greater than alpha 1. So here when we apply equal torque on the hollow cylinder and solid sphere having the same masses and same radius, then the angular acceleration of the sphere is coming greater than the angular acceleration of the hollow cylinder. We know this relation, omega is equal to omega naught plus alpha t. So in a given time, the body having larger angular acceleration will acquire greater angular velocity. So obviously here omega 2 is greater than omega 1. Now see this example, there is a car whose mass is 1800 kg, and now the distance between front and back wheel axle is 1.8 meter, and the center of mass or the center of gravity at this point, and the distance of the center of gravity from the front axle is 1.05 meter. So you have to determine the force exerted by the ground on the car. That means the force exerted by the ground on the each wheel. That is, suppose at this point the force exerted by the ground is N1 and the force exerted by the ground is N2 on the back wheel. And at the center here the force, that is the weight of the body, that is the weight of the car, that is 1800 into 10. So I have written N1 plus N2 is equal to 1800 into 10. I have taken g is equal to 10 meter per second square for easy calculation. So this is N1 plus N2 is equal to 1800 into 10. This is the Newton forces here. Now for rotational equilibrium, you apply rotational equilibrium about the sea. So this will be producing the torque this side and this is to this side. So the total torque due to these forces should be equal to 0. So that is N1 into 1.05 minus N2 into 1.8 from here to here that we need, sorry, this one. So N2 into 1.8 minus 1.05 is equal to 0. So we can write here N1 into this, and this you subtract it. When we subtract it, we get N2 into 0.75. And N1 upon N2 is equal to, we have got here 5 upon 7. So we can put the value of N2, N2 is equal to 7 upon 5 N1. So we have put the value of N2 in this equation and this. So we have got value of N1 is equal to 7500 Newton. And when we put the value of N1 in this equation, we can get N2, N2 is equal to this much, that is 10,500 Newton. So the front wheel, this N1 is experiencing 7500 Newton force from the ground upward, and this is experiencing 10,500 Newton force.